2.5 for today, and any homework questions if you guys have any here. So tonight, since I finally got the semester 2 up, so 2.1, 2.2, 2.3 is due tonight. And then if we get through 2.5 completely all today, we'll see. Then it'll be due on Monday. If not, then it'll be due on Wednesday. Thinking of an exam maybe Wednesday of next week, or we push out to Friday.
I like Friday.
Friday is Friday. We have
Oh no, that's on Wednesday.
and I have a last exam on Wednesday.
Okay.
So Friday good.
Could we do the test on Friday? I have 2.5 due on Wednesday, so we have a little more time. I know the last year.
I like that.
I don't know.
Or not to be. Is that the wrong one?
Actually,
no, it's not.
I'll give it to you guys this weekend for sure. So how about that?
That is a lot better.
Better? Okay.
I like that a lot.
I figure the whole point is not to kill you guys, but just to keep on going, progressing through the class here. So,
Thank you.
yeah. So come with homework questions on Monday, and we'll go from there. Exam is next week on Friday, and I'll give you guys a study guide this weekend for it, so we can have that for
Yeah, that's
us.
a lot less stressful now.
Okay.
Wednesday.
Doing things on a Wednesday, I'm like, are we back to midterms already? Well, that exam?
All right. What other exams do you guys have on Wednesday?
Oh, yeah, poetry recitation.
Poetry. Okay.
And if you're in Latin, like, there's a big.
Ours,
Latin
poetica.
lesson.
You can do that.
Yeah, ours.
Well,
poetry.
actually, Abe, your schedule might be different.
And I'm in Latin, so a lot of us have Latin tests.
Y'all be like
which is
alike.
awesome.
I had a test already.
You don't know either?
Okay. So class, the whole goal here, 2.5, is finding zeros or finding x-intercepts or solving for polynomial functions. Whichever way you say it, that's actually meaning the same thing. And so we, absolutely. That good? All right, so let's jam. Not really doing any information here besides the fact that we're putting it all together. So we've done, maybe one thing called the rational zero test or rational root theorem. So we practiced synthetic division, is that right? We got this whole thing about the remainder theorem, remember that? If you divide everything, the remainder is the same thing as just plugging in the value, right? And you get the remainder if you just need to see the remainder. And so we have one more thing to do. And so this is something called the rational zero test. Other textbook call it the rational root theorem. Your book called it, write it the way your book writes it here. The rational zero test. And then we'll begin. So say you have a polynomial. And this is going to look funky at first here. It says this, it says a sub n x sub n, which means it's a number coefficient in front of x sub n. Then you go down.
Does that, I don't think that's a sub n on x.
Oh, that's a exponent. So this will n here and that will n are connected. And I'll show you the example because I know this is getting abstract like crazy here. All the way to like say a squared x squared plus ax plus a naught. Tristan.
Is this stuff going to be on the test?
When we start doing examples, yes, not the definition. So not to scare you.
Everything's scary in math. It's not too bad.
You can't read the little X.
Sure. So let's see.
There has to be some.
A sub n minus 1. This is x to the n minus 1 plus, and then dot, 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 all the way to the end. This is a squared, or a to the sub 2, a sub 2, x squared, plus a sub 1, x, plus a, and then we call it a naught. We don't call it a sub 0, we just call it a naught. Right here?
Yeah.
Very true. So what it's saying is this, and let me give you the example so it doesn't get confused. This is the math way of saying any polynomial whatsoever in the world. Okay, examples would be like this. Right, if you say 3x to the 4th plus minus 7x cubed
So
plus
that's just
2.
how you write the function for, and you can put any polynomial ever in it.
Yeah, so this is the generalized way of writing a polynomial in mathematics. And so these little connections right here are saying, hey, that's the connection to here. This is the connection of any degree of 4, right? So this is kind of like the 3 is connected to that piece there. And then that little -7 is connected to that piece there. We good? Or does that make sense?
So the sub, what is it called?
Subscripts?
Subscripts are for like identifying
Which one goes where?
which one goes where.
Yeah. And if you need zeros in there, you can plug in zeros in front and they'll have no degree.
So it's supposed to be A2 plus X2. Wait, no, A sub 2 X.
X squared
Yeah, A sub 2 X squared. And then
Plus
it's just,
a sub 1, there's like a little 1 right here. A sub 1 and then just x, because we don't write exponents of 1, plus a to the 0. And so that little 5 is kind of like the last connection. There's your a sub, there's 2 x's kind of like that. We good? Does
What's
that
the
make sense?
sub in the bottom?
Where?
Because in the alphabet, like the equation on the bottom, it's
Uh-huh.
like three. Then where's the A sub?
The
n?
sum is just to denote that not all the A's are the same.
Oh,
Yeah.
okay.
Thank you. Yeah. So they're connected to the one with the same exponent.
Oh,
They're just the connection pieces.
but like the bottom one, that's what will be on the test, right? Just.
Not even that much. Yeah, but something like that. Yeah. So we'll get to an example in just a bit here. We are out of here when?
10 o'clock.
35.
35.
10
Okay.
o'clock.
Okay.
3 minutes ago. Okay. Are we good there? So that's the generalized formula. We good? Okay. So the rational zero test is this. It says if this has a rational answer, which means it's a fraction or an integer, right? The zero, the rational zero, will be, actually I should equal sign. The rational zero equals P divided by Q. And then I'm going to define what in the world is P. P is a factor of a sub 0. Q is a factor of, once we put this together, you guys will sort of see it here. So let's kind of define it. Let's give an example, and then we're going to go from it.
factor A1.
So P equals a factor of A naught. It's this guy over here at the end.
Oh, that's like the 5.
That's the 5, And then this one, Q is a factor of this guy. So let's do an example of it first, and then we'll sort of see it.
So you could just do one of them.
So another way of saying A sub 0 is the last coefficient in the
It's the constant term. If you want, you can put constant term, because that's a, so we have, this guy has a very specific name. That's why it has a very specific name. This guy's called a constant coefficient. And this guy over here, the one in front, we call this a leading coefficient. And those guys have special names. The other ones in the middle don't have special names, but these two do. So,
and so A sub n would be the leading coefficient.
So let's go through one problem very slowly. We good? And then we'll get the hang of it. Then we'll do maybe 2 more, and we'll sort of like, oh, that's easy stuff. We good?
Sure, P is a factor of A sub 0.
P is a factor of A sub 0.
And then Q is a factor of A sub, or A sub n.
A sub n. Perfecto, guys. We have come to the end of, remember how we did factoring? Factoring was only works on a squared, right? Or x squared, right? We want to be able to solve polynomials of n of x to the 3rd, of x to the 4th, x to the 5th. We want to be able to solve like the higher end degrees. And this is the way we do it as humans.
So we're done with factoring
We are done.
forever?
No,
We-
nothing's forever.
we are done as far as learning any new material, how to factor, yes. So this is it right here. So when you get down to x squared, you can factor or you can use quadratic formula. That's what we learned in algebra 1, right? Algebra 2 now says, if I go to x to the third or x to the fourth, how do I do that process? Because I can't factor. Factoring works for x squared. So we're good. So now we sort of extended that factoring process. And here's how we do it. Let's go with it. You guys ready? Boom. Example number 1. It just says find all the zeros of this guy here. 2x cubed plus 3x squared minus 8x plus 3. And we'll sort of see all these parts coming together. And I'm going to turn it into black ink here. Okay, so what do we got here? So it says this: if there are zeros, and those zeros are either integers or fractions, we're good? Those zeros are going to be p over q. Did you guys ever hear the expression, mind your p's and q's? Heard of that before?
This is how we can find zero.
Uh-huh. I know, isn't it fun? Because you figure like, oh, this factoring process, right? Even beyond that, it just becomes this sort of, it is a guess and check game. We're good? So let's go for it here. So first things first is, we're going to find out p over q. But first of all, we're going to figure out the, let's see how the way your book writes it here. Okay. I'm going to go p over here. Actually, yeah. And what we're going to do is we're going to think about 3. We're going to think about all the different factors for 3. That's pretty easy. That's just going to be plus or minus 1, plus or minus 3. Are we good? Because it's a prime number. Moving on to q, that's lowercase. Now, sometimes books put them in uppercase, sometimes they put them in lowercase. So then for q, we look at all the factors of 2. So plus or minus 1, plus or minus 2. Now we put these guys together. So we want to, yep, all the different variations. You guys ready?
We have to go through every one.
To keep the list a little smaller, we are going to put plus and minus in front of it, just so it doesn't get huge. So what I like to do is I like to take q being 1 first. So it's going to be 1 over 1. It's going to be 1 over 3. Everybody good there? Got that one? And this little q being a 1, because you know 1's going to always be a factor, right? So you know that if I divide by 1, these guys are going to be here right away, right? The p by itself terms. Okay, then let's divide everything by 2. So then we go, next list would be plus or minus 1/2, plus or minus 3/2. So 1, 2, 3, 4, 5, 6, 7, 8. Guys, we've boiled down the zeros to 8 possibilities. That's what we've done.
Wait, so those are all zeros, or those are all possibilities?
Possible zeros.
Okay.
Now the p over q will be a factor of those, right? One of them. So what we do, generally speaking, if we start off with a x to the third polynomial, what we do is we use the p over q stuff, and we get it down to x cubed. Then what we do is we use p over q again to get it down to x squared. Once you get it down to x squared, you are either going to factor or you're going to use the quadratic formula. We good? And again, if you stop higher, if you start out x to the 5th, you just go down the list until you get to x squared, boom, then you get the rest of them. We're good? But the whole goal is to get to x squared, and we are done. Okay. Remainder theorem. What do you guys think about remainder theorem? What was it all about? I think it said this. If you plug in the value and the remainder is 0, you know that to be a factor. We good? So guess and check. Here we go. Should we plug in a positive 1, a negative 1, positive 3, negative 3, positive 1/2, negative 1/2, positive 3/2, or negative 3/2?
Go with positive 1.
I figure let's go with the easiest possible one. Absolutely. Positive 1, plug in. That's nice because all we do is we forget about the terms themselves and we add this up. Is this true? Will this give me a 0?
Oh,
Abe got it right. Okay, that is a 0. Ding, 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 ding. Awesome. So now we know this. We know right away, we know that x minus 1 is a factor. We good? Everybody good there?
but I thought we used positive. You have to use X.
Remember the rational root theorem says if this, we plug in the 1 here, right? But then to write it as a factor,
Oh,
we write it like that,
oh,
right?
and then it's the 0.
Mhm.
Correct, and then X.
So then you divide the original polynomial.
Oh, yes. So we have to divide x minus 1 into this. Now,
You get a binomial, and then you can factor these together.
perfecto. My question is this, guys. Do we want to do it the long way or the short way? Long or synthetic?
Synthetic.
Synthetic. Here we go. So we're going to take this 1. We're going to bring down the 1 here. Put our division symbol here. And we're going to write 2, 3, -8, 3. And what has to be this remainder? Yeah, we know that remainder has to be 0, right? So we're just going to double check it as we put it in.
Yeah, I thought we used X times 1 for
Just the 1. And when I was learning this stuff too, I would always get the sign messed up. All right, bring down the 2. Are we good there? Multiply. 1 times 2 is 2. Bring down the 3 times 3 plus 3 plus 2 is 5. Multiply by 1 to get back up. -8 plus 5 is -3. Multiply by 1 to get up. And voila. Okay, so because of that, what is the remaining polynomial?
2x squared plus 5x plus 3.
Is it a minus or a plus here?
I think we got a -3 on our hands, right? Boom. Okay, so now the question is this. We're down to x squared. Awesomely awesome. Quadratic formula or factoring? Which one do you guys want to do? I think we might even just do factoring here. Let's see. Yeah, I generally like factoring as long as my endpoints are prime numbers, because then I can find those really quick, because I have to do guess and check. If they're not prime numbers, then I'm thinking, oh man, maybe just quadratic formula, but whichever is faster here. So let's see. Only way I can get a 2x in front will be a 2x times x. Only way to get a -3 in the back is a 3 and -3. Now where to put it?
2x minus 1 times X.
2x minus 1 plus, yeah. So this one gives me a 6x right over here. This one gives me a -x, and that gets me that 5x in the middle. Okay, how about write it like this here? Can you write the polynomial in factored form first? We're good? And then can you give me all the zeros? Okay, so writing this in factored form, let's see, I'm going to write it next. So this little guy here, f of x is equal to 2x cubed plus 8x squared minus, oh, sorry, 3. Sorry, it's 3x squared. Plus 3 is the same thing as x minus 1, 2x minus 1, x plus 3. There's my factored form of that equation. Are we good?
How'd you get x minus 1 again? I missed that bit.
That was from our from this little guy right here.
Wait, so you only need to guess and check until you get 1 correct, right? And then
You have to guess and check until you get one correct.
I thought you had to guess and check all of them, and that was how we were gonna do it. And I'm like, no.
But how did you know that it was x minus 1?
Sure. So if f of 1 plugged in gives you a 0, you know that x minus 1 is the factor. And the way we solve it is it's 1 comes in as the solution, and then you turn it into a factor. So you gotta undo it so that it's set equal to 0.
What about all the rest of the zeros? Can't you use one of those and get a factor too?
Oh, absolutely. So let me make sure. Dylan, did I answer your question?
No.
No, okay. So let's do that first, and then Isabel, I'll answer yours here. Let me do it with laser here. 1 second here.
Oh, yes, that is beautiful. Oh,
Got a laser. Love it. Okay. So Dylan, if we plug in a 1 and we get a 0 factor out of it, right? Then we say, okay, that's the solution. That means x equals 1 is the solution.
Yes, but how would you know that it was a 1?
We guessed. If we get a guess, if we put 3 in here, it would have went wrong. If we put 3 halves in here, it would have not given us a 0. So you know it when it gets you that 0 right there. We were just good guessers with Abe. And Abe said, let's plug in a 1, and it worked out well. So if we ever go gambling, we take him to the casino with us.
So do you specifically choose from P over Q?
Yeah.
You got to choose from one of these, and you choose them, and then if it does not work out, if you don't get a 0, you just try another one. It doesn't work out, just try another one until it works out.
Zero, is that number
I
not
don't know
zero
how to
or
explain
something?
this.
Until you get a 0, Dylan, okay? Isabel, go
You
ahead.
don't get a zero when you plug it in, then is that number not a zero?
Correct, yeah, you just cross it out, you go on to the next one.
Okay.
Because these are possible zeros, these are not true zeros. Okay, Dylan, back to you, just to make sure, we good? Isabel, you had another question, didn't you?
I think that answered it.
Okay,
Less confused.
so we'll practice a little more as well here. Okay, class, the other piece is this. Notice that if I were to solve this, actually, let's solve it first. Let's solve it first, then we'll go on. Get back up the pin. And so if this is solved, notice we're going to set each of them equal to 0. So this is plus 1 from both sides, and there's our original x equals 1. This one, if you're to plug in, oh, look at this. If you add 1 over here, divide by 2, that means if we would have plugged in a 1/2, it also would have given us a 0 remainder. We good? That was the other 0 sticking in there. And if we were to plug in a -3, that was the other hidden answer. So there it is. There's my 3 answers. So I know. Say again, say again.
You wrote x plus 7 up there, but it looks like equals 0, but it's x minus x plus 3.
No, it's x plus 3.
Oh, okay. It wasn't that squiggly enough. Okay. Let me go more squiggly.
What's the problem? You know,
Better. Some people thought it was a 7.
confused. Calm down.
Okay, so what do we know of this graph? We know this here. At x equals 1, it hits the x-axis. At 1/2, it hits the x-axis. And at -3, it hits the x-axis. We good?
Oh, then we did an up or down thing.
And if you want to, we can do absolute the up or down thing. Look at this, boom, and then we have ourselves a
Oh,
graph.
that's the part that I'm so lost on.
How do we do that again?
Okay.
How do you know it's going from the bottom?
Because it's x to the 3rd power.
Oh, and
Oh, right, and the x to the third always starts from the
Starts
bottom.
low, ends high, as long as this guy's positive.
Oh, and then, so,
Oh, yeah.
even numbers start, is it even numbers?
Even
start high?
even powers will start high and end high,
Yeah, and
as
then,
long as the number in front is positive.
So Monday and Wednesday, we're gonna review all this.
Yeah, bring the homework questions as well. That's what I want you to do. Charlie, did you have a question?
It was like a long question, but it's just, when I'm lost, like, there's like one where it's like, it goes up and then it goes through the line and then it like touches on another part, so it's like,
Sometimes it touches, sometimes it crosses, right?
on the both, in like the same equation.
Yeah, please do bring me those homework questions. Yeah, and we'll solve. It's just a matter of what exponent is on it. I don't want to go through it now because I want to finish up this section here. So the homework is not to graph it. The homework is just to find these answers right here. Okay. So we've solved it. This is awesome. So there it is. There's your answers. You can write them like this individually. You can write them as like this as well, and that's fine. You can write them, those are my answers, just as a list. Cool. Another one. Let's go with it here. Of course, we get more complicated here. So The process is all the same. We good? Just so you guys know, the process is always the same. Let's see, what time do we have? Yeah, yeah, that's too large. I don't want to get too big. Yeah, let's try this one here. Exercise 2. Find me all the zeros of 6x cubed minus 4x squared.
Is P the first one or is P the second one?
P is the last one.
Last one.
Okay, so the last one or the third.
Do we need to add in the negative for the 2, or is that?
Isn't it plus or minus 2?
Yeah, it does that. Yeah.
I think we can probably get through this one. Yeah, that'll be good to go. A little tiny bit more difficult, not by much. And then we have one more to go, but I'm not sure we'll have time to get there. All right, P. P is all the factors of -2. Doesn't really matter on the sign. So plus or minus 2, plus or minus 1, plus or minus 2. All right, anybody switch them around accidentally? Q is going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. That's this piece here. That's this piece there. So now we have P over Q. Oh boy. Let's see how this works. So if I assign 1 to be the Q value, to talk to them, are we at the same place as I am? So Q being a 1, it's going to be plus or minus 1, plus or minus 2, because it's just these pieces right here divided by 1, which just keeps them. Okay, now we're going to divide by 2. So kind of careful here. Notice if we divide by 2, that gives us that little 1/2. But if you divide 2 by 2, that gets you back to 1, and we already have plus or minus 1. Are we good? So no need to write down plus or minus 1 again, because we already had it. Okay, are we good there? Does that make sense? That's a little conceptual thing that is not written down. Let's start dividing by 3 now. Dividing by 3 gets us 1 over 3, and it gets us 2 over 3. That's cool, that's done. And then when we do 6, that's going to give us 1/6. And then when we get to 2 over 6, that gives us a 1/3, right? And 1/3 we already have, so there's no need to write it down again. Cool. So we have 1, 2, 3, 4, 5, 6, 12. 12 different possibilities here. Oh, bummer. So yes, I'm going to plug in the 1 just to show you that it does not work. If you plug in a 1 into here, it gives you 6 minus 4 plus 3 minus 2.
Oh, but fractions are long because when you square fractions, they get small.
What's that going to give us here? That's going to be 2, 5, 3. 3 is the answer. 3 is the remainder. Bummer. Okay, 1 does not work, so scratch that out. How about -1? Let's try -1. Maybe -1 works. So with -1, the signs change.
We do the same. We do the same.
Oh, really? Because this would be -1 times -1 times -1. It would be a -6 here. This would become a -1 times 1, again a -4. Oh no, this is becoming way negative. Forget that. That's way, way negative. Once I see that, I don't even want to go on, right? Because then I know it's not going to give me a 0. negative 10, 13, negative 15. Okay, so that's gone.
I don't think the twos were either.
Twos, okay. Abe says the twos don't work either, so we're kind of like,
I'm just
that's
gonna do
gone,
the
that's
check.
gone.
Yeah, that's fair.
Abe and I both.
So the ones don't work then?
Yeah, the ones don't work, and Abe says the twos don't work either. So now we're into fractions here at this point.
Darn it. And fractions are annoying when you cube them, because they get really tiny.
Ah,
It's better be one.
how about this here? Let me give you a guess just because I like you guys. I'm gonna give a guess of 2/3.
Yeah, I was about to say that was mentioned.
No, there you go. Yep.
2 and 3 fit into all of those numbers.
Okay, I'm gonna have to go on the next slide here. Try 2/3. Let's try it together. Try 2/3 together. This would be 6 times 2/3 cubed minus 4 times 2/3 squared plus 3 times 2/3 minus 2. Okay, 3. So let's see. It's going to be 2 times 2 times 2, right? It's 2 to the 3rd power. 3 times 3 is 9 times 3 is 27. Minus 4. This is going to be 4 over 9. Oh, this is interesting. Look at this. The 3's will cancel, right? So that turns into a 0. Okay, that's cool. So that means somehow this might have to turn into a 0, and that'll be great. Yeah, you could do that. I could go 6 times 8 is 48, but I'm thinking maybe let's reduce this if we can.
Why is this over 3? Yeah, it'd be 2 times 8 over 9.
Okay, so if you divide 3 and 6 have 6 and 27 have a 3 in common. So divide this out by 3, becomes a 2. Divide this out by 3 becomes a 9. So that makes 16 over 9. Oh, nice. Look at that. That's a 16 over 9 plus 0 because I got the 0 from here. Awesome. I like it. Oh, good. So 2/3 is what works. That's the only difficulty with this stuff
Minus
here.
2/3 is the factor.
So x minus 2/3 is the factor, but we want to do synthetic division to help us out.
Oh, that sounds hard.
Oh, we're not done yet. We haven't done like anything yet.
Say
You
again?
have to multiply everything by 2
fraction like that.
Oh, no, that's
Like, how do you do that?
Oh, right over here?
Real fast.
So guys, question is right here. So instead of multiplying this and getting a 48 out of 27, then having to work with bigger numbers, I would rather work with smaller numbers. So anytime I can divide things out or reduce a fraction, I would go ahead and do that. Makes it a lot simpler to work out later on. Always think of reducing. Okay, let's bring this down. So 2/3 comes down. I need a 6 minus 4, a 3, and a minus 2, and we better get a 0 here. And we are up against the clock here, so let's see if we can finish. 6 comes down, and then off to the side, maybe you might have to do this here. So it's going to be 2/3 times 6. Let's see what that is. What's that? 6 again.
This is way easier than it looks, guys.
Yeah, it is.
That's 6 into 3, or you can, this one's small enough, Dylan. I think in 6 times 2 is 12 divided by 3. Is that small enough there? Landon, we good? Yeah. Those are small enough numbers to work with here. And that becomes a 0, and 0 times 2/3 is still 0. I like that. 3 comes down, 2/3 times 3. 2, right? Yeah, 2/3 times 3. 3's cancel, leaving us with a 2, and that's a 0. Perfect. A remaining polynomial is
6x plus 3.
6x squared. Plus 3. Okay. Okay, I think we're good here. Let's write this out now.
Oh, now we need that. We need to factor that.
Yeah.
We can factor that. Only problem is the x in the middle is gone.
So quadratic.
I'm thinking quadratic formula would probably be best. So, and if you want to just sort of keep it kind of separate, that's fine too. I'm going to go 6x squared plus 3 equals 0, right? I'm solving this one. And this one's going to be 0, is that right? Everybody okay with 0? Because the b value is 0, plus or minus?
Did you just write plus or minus?
Yeah, plus or minus in front though, right? It's right here. Minus 4. Sorry guys, that's me. Oh. Negative 4 times a times c, I think, over 2 times a. That's the quadratic formula.
Oh, there it is. It just took.
All right, let's go with it. Let's see, finish up before the clock here.
What was that?
What do we have here? Anybody? 24 times 3. 24 times 3.
78.
78? 78, 72.
I really don't know. I just honestly said a number. I didn't realize it
Close.
was that close.
Close guess, Camille. Ooh, it's a negative inside here. Oh, wow. I think I learned about negatives last time. 7, and then 72 is 9 times 8. Is that right? 9 is a perfect square. This is 4 times 2. That's perfect squares. Plus or minus?
7. What? That's not real.
I think 6i. Right, 6i.
No, it's supposed to be perfect.
What are you doing?
Boom. Can we do it okay?
Tristan's hammering a push pin into his notebook.
Okay.
Then you can divide both those by 6.
We can divide both those by 6. That becomes a 1. That becomes a 2. And we got ourselves a radical 2 over 2.
Oh, that is.
Ah!
Okay, list for me all the zeros.
0, 0, 0, and 0.
It's 2/3, and then,
Wait, oh, we can just put that.
Yep, that's exactly
That
what I
is-
said.
Perfect. Okay, are we good there? So that became a little more complicated, right? That became something we had to do by, again, but it's still in a sense simple because we just did quadratic formula. And now that we know that we have I values we can pull out, whenever you have a negative is inside the square root, you pull it out as an I value on the outside. Okay, any questions on this? I just want to make sure that you guys are okay there. You guys have enough to start the homework. And then there's one extra little thing that I have not got to. Let's see, so 55, let me just write this in. You guys can do 55 to 71. That's one section of homework. If you want to try to figure out 47 to 53, that's the other section. Now, not all those problems, right? There's just a handful of problems there. Those are the only 2 sections I want you guys to try.
Oh, I have a question. Can we have one, or if we have 2.5, do one more day?
Yeah, absolutely. Class, you guys are dismissed, and I'm gonna